Welcome viewers, in this video we will see the details about the decoders in digital electronics. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic decoder. A decoder is a multi-input, multi-output logic circuit which convert coded input into coded outputs where the inputs and output codes are different. So that decoder is a multi-input and multi-output logic circuit. That is nothing but n input and 2 to the power n output. Right? It is just opposite of the decoder. This is encoder. Encoder means 2 to the power n input, n output. Decoder means n input and 2 to the power n outputs. The diagram shows the general structure of the decoder circuit. As shown in the diagram, the encoded information is presented as n inputs, producing 2 to the power n possible outputs. The 2 to the power n outputs values are ranging from 0 to 0 through 2 to the power n minus 1. Now we will see the diagram having n input and 2 to the power n possible outputs. Now we will see the block diagram how we are producing the output. So this is the decoder, n input, 2 to the power n outputs. This is the n possible inputs are available. This is the 2 to the power n possible outputs. In order to enable or disable the decoder, we have enable input is available. If enable input is given, then only the decoder will produce the output. If the enable input is 0 means the decoder is disabled. Now we will see one example. Usually a decoder is provided with a enable input to activate the decoded output based on the data inputs. When any of the enable input is unassorted, all the output of the decoder is disabled. Right? In order to enable or disable, we are using the enable input. If enable input is not there, we will not get any output. Right? So we have n input, 2 to the power n output. Let us consider n equal to 2. So that 2 is to 2 to the power 2. That is 2 is to 4. Right? So 2 inputs and 4 outputs. There are 2 input. 2 input mean 2 digits. A, B. 4 output mean 4 digits. Y3, Y2, Y1, Y0. 4 possible outputs. Right? 2 digits mean 2 input mean here the 2 digits. Right? 2 digits mean there are 4 possibilities available. The input may be 0, 0, 0, 1, 1, 0 or 1, 1. There are 4 possibilities. So 2 digit 4 possibilities. So these 4 possibilities will produce the 4 different outputs. For example, A and B is 0, 0 mean Y0 will be 1. Other in outputs are 0. This is the first possible output. 0, 1 means A and B is 0, 1 means Y1 will be 1, then other outputs are zeros. A and B is 1, 0 means Y2 will be 1, other outputs are 0. If it is 1, 1, A and B is 1, 1 means Y3 will be 1, other outputs are zeros. Right? So with the 4 possible inputs, we are getting 4 different outputs. That is Y0 is 1, other are 0. Y1 is 1, other are 0, Y2 is 1, other digits are 0, Y3 is 1, other digits are 0. So we are getting 4 possible outputs. So this is the function of the decoder, right? 2 input mean 2 digits, 4 possibilities. Based on the 4 possibilities, we will get the 4 different output. That is Y0, Y1, Y2, Y1, Y3 may be 1, other digits are zeros. So this is the function of the decoder. So in this video we discuss the basic block diagram of the decoder and we discuss if n equal to 2 what is the possible output. We discuss the input as well as output. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the 2 to 4 decoder, also called as binary decoder. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic 2 to 4 decoder. What is a decoder? A decoder which has an n bit binary inputs, n inputs, and one activated output of 2 to the power n possible output code. Because of this n input and 2 to the power n output, it is also called a binary coder. 2 to 4 decoder is also called a binary decoder. So we have n inputs and 2 to the power n output. That is the basic function of the decoder. Here n equal to 2. So 2 is to 2 to the power 2. That is 2 is to 4. We are having 2 possible inputs and 4 possible outputs. Right, now we'll see the detail. A binary decoder is used when it is necessary to activate exactly one of the 2 to the power n output based on the n bit input value, right? 2 to the power n output and n bit. The diagram shows the 2 to the power 4 decoder and truth table. First we will see the truth table of 2 to 4 decoder, right? So the inputs A and B, we know the two input means 2 digits, 4 possible outputs, y3, y2, y1 and y0, 4 possible output, and one more we have enable. If enable is 0, whatever may be the input, the output is 0. The decoder is disabled, that is disabled. If enable is 1, then only the decoder will produce the output. In order to enable or disable the decoder, we are using enable input, right? If the enable input is 1, A and B, 2 digits are there, so there are 4 possibilities, 0, 0, 0, 1, 1, 0, 1, 1, right? Suppose A and B is 0, 0, we will get Y0 as a 1, remaining terms are 0. If A and B is 0, 1, Y1 will get the output, Y1 as 1, remainings are 0. 1, 0, if A and B is 1, 0 means Y2 will be 1, the remaining digits are 0. If A and B both are 1, then we will get Y3 is 1, remainings are zeros. So with the 2 digit input, 2 possible 2 digits, we are getting 4 different outputs, right? Because of 2 digit, normally we are having 4 possibilities. This based on the 4 possibility, the output may be Y0 may be 1, or Y1 may be 1, or Y2 may be 1, and Y3 may be 1. The remaining digits are 0. So we are getting 4 possible outputs, right? Right. So diagram shows 2 to the 4 decoder. Next we will see the logical diagram. There are 2 inputs, is A and B, and into 4 outputs. Each input representing one of the minterm of the 2 input variable. The 2 inverters provided the complement of the input, and each of the 4 AND gates generate one of the minterm, right? So we have here we need A and B as well as A bar and B bar, so that we are using 2 inverters to get A bar and B bar, that is given here. Now we'll go to the logical diagram. We'll see how we are getting 4 possible outputs, right? So this is the logical diagram. So this the line, this green color line is A, input A. First we will see the inputs. From A, tapping is taken and connected to NOT gate. So after NOT gate we will get A bar, complement of A. This red color line is the input B. Tapping is taken and connected to NOT gate, so that we will get B bar. Right, now we have A and B as well as A bar, B bar. 4 possible inputs are readily available. In order to go with the 4 possible output, we are using 4 different AND gates. 4 AND gates are available, and one more input is enable. Enable is connected to all the AND gate. Enable is connected all the AND gates, and A and B is connected, either A and B or A bar, B bar. So the enable is 1, then only we'll get the output. If enable is 0, because of AND gate, one input is 0 means totally all output will be 0. Let us consider the enable is 1, right? Now we'll see how we are getting the 4 possible outputs, right? First Y0. Y0, what is the possible? A and B should be 0, right? We already discussed in the truth table. A is 0, B is 0 means we will get Y0 is 1, other outputs are 0. How it is possible? 0 0 means we are connecting A bar and B bar. A 0, A bar means 1, B is 0, but B bar is 1, right? So you are connected A bar and B bar. You connected here the A bar and B bar. This A bar is connected, this B bar, not this one. Here B bar is connected. So A equal to 0, B equal to 0 means A bar and B bar will be 1. So here we will get the high output. Right. What about the other? Here 0 0. Right. A is 0 means A bar will be 1, but B is 0. B 0 means automatically will get 0 as the output. Right. Here also A is 0, B is 0. So here one 0 is there. So we'll get 0. Here both A and B is 0 0. So we'll get 0 as the output. Right. So this is the first possible. Y0 is 1, Y1, Y2, Y3 are zeros. For the input 0 0. Right. Next possibility is 0 1. That is applicable for Y1. So B equal to 1, but A is 0, but we connected A bar. So what happened? A is 0, A bar is mean A bar become 1. So that is here we both will become 1. Similarly here A is 0, but A bar is 1, B is already 1. So what we'll get? We'll get 1 as the output. But here what happened? This 0 1, 0 means 0 and 1, right? The B is 1, B bar become 0. So we'll get 0 as the output. Similarly here A is 0. So here one input is 0 means totally will get 0. Similarly here also will get 0. Right? Only this second output only Y1 will be 1. Remainings are zeros. Right. The third possibility is 1 0. For 1 0 we are getting Y2 as 1. How it is possible? A equal to 1. B is 0, but B bar will be 1. So both are 1 means we will get the high output. All other automatically it become 0. Right? See this 1 1 1 we are getting in a order. Right. For the fourth possibility is 1 1. So both are high level, so we will get the 1 as the output. When other terms the bar is there. B is 1, B bar becomes 0. So totally the output become 0. Right. See this, now we are getting Y1. Y0 is 1 when it is 0 0. When it is 0 1 we will get Y1 is 1. When it is 1 0 we are getting Y2 is 1. When it is Y3 is A and B is 1 1 we are getting Y3 as 1. So we are getting these 4 possible output. Accordingly the inputs are connected. Here A bar and B bar is connected. Here A bar and B is connected. Here A and B bar is connected. Here A and B is connected. Because of 1 1 A and B is directly connected. Because of 1 0 A B bar is connected. 0 B bar is connected. Here 0 A bar is connected. Here both are 0. So A bar and B bar is connected. So automatically we are getting the 4 possible outputs. So in this video we discussed the 2 to 4 decoder, also called a binary decoder. We discussed the truth table. Based on the truth table we discussed the logic diagram, and for each and every possibilities we verified the output also. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the 3 to 8 decoder. Details about 3 to 8 decoder. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic 3 to 8 decoder. We know that decoder is a device having n input and 2 to the power n output. Here n equal to 3. 3 is to 2 to the power 3. So that 3 is to 8. From 3 possible input we are getting 8 possible outputs. That is the 3 is to 8 decoder. The diagram shows 3 to 8 DIN decoder. Here 3 inputs are decoded into 8 outputs. Each output represents the min term. Because of 8 term, it is each output represents the min term of 3 input variable. The 3 inverters provide the complement of the inputs. We have A, B, C. 3 inputs mean we need A bar, B bar, C bar also. For that we are using inverter. Each one of the 8 AND gate generates the one of the min term. We are using 8 AND gates, right? So these inverters used to provide A bar, B bar, C bar. Then finally we are using, because of 8 output, we are using 8 AND gates. Enable input is provided to activate the decoded output based on the input data ABC. So the enable input also connected to the AND gate. If enable is 1, then the decoder will produce the output. If enable is 0, the all output will be 0. Right. So we have the input A, B and C. Also we are having the enable input. Now we'll see the truth table of 3 to 8 decoder. So this is the truth table available. The inputs are A, B, C and also enable. And this is the 8 possible outputs, Y7 to Y0. Right. If enable is 0, whatever may be the value of ABC, the all outputs are 0. In AND gate, the enable is connected. Enable is 0 means the AND gate will produce all outputs are 0. So this enable is used to enable the decoder or disable the decoder. For other term, the enable is 1. Right. Now we'll see how the possible outputs are there. Because of 3 digits, 3 inputs, there are 2 to the power 3, 8. 8 possible combinations available. 0, 0, 0, 0, 0, 1, 0, 1, 0, up to 1, 1, 1. That we know that, right? 3 digit, 2 to the power 3, 8 combination. Based on this 8 combination, we are getting 8 different outputs. We will see one by one. A, B, C, all are 0. 0, 0, 0 means Y0 will be 1. Other digits are zeros. Then next combination 0, 0, 1 means Y1 will be 1. Other terms are zeros. Then third combination 0, 1, 0 means Y2 will be 1. Other terms are, other digits are 0. Fourth combination 0, 1, 1 means Y3 will be 1. Other digits are 0. Fifth combination 1, 0, 0 means Y4 will be 1. Other terms, other digits are 0. Then the sixth combination 1, 0, 1 means Y5 will be 1. Other digits are 0. Seventh combination 1, 1, 0 means Y6 will be 1. Other digits are 0. Then the last combination, eighth combination 1, 1, 1 means Y7 is 1. Other digits are 0. Right. So the 3-digit input, 8 possible combination. Based on the 8 possible combination, we are getting 8 different output. That is, we are enabling either Y0 or Y1, Y2 up to Y7. So that we are getting 8 possible output. So in the logic diagram, according to this, we need to connect the inputs. For example, A, B, C, 3 inputs. Similarly, we have A bar, B bar, C bar. Right. So totally 6 inputs, as well as 1 enable. Totally 7 possible inputs are there. So either we connect A or A bar. Similarly, B or B bar or C or C bar. Accordingly, if you connect, we will get 1 as a output. For example, here A is 0, B is 0 and C is 0. 1 input is enabled. Remaining 3 inputs are A, B, C. If we connect A, B, C, we will get all are 0. But we need to connect A bar, B bar, C bar. A, B, C all are 0 means A bar will be 1, B bar will be 1, C bar will be 1. So automatically this AND gate will be enabled and Y0 will be produced the 1 as a output, right? 0 means we need to connect A bar. Here 0 means B bar. Here 0 means C bar. Similarly here A is 0 means we need to connect A bar. Here B bar. Here we can connect C directly. Here A bar, B, C bar. Like that we need to connect, so that we'll get the corresponding output. Now we'll see the logic diagram. The same thing we will see how it will produce in the logic diagram. So this is the logic diagram. So the input A, this green color line, input A available. Tapping is taken, AND gate is connected, so NOT gate is connected. So after NOT gate we got A bar. This red color line is the input line B. Here also one tapping is taken, connected to NOT gate, so we'll get B bar. This blue color line is the input line for C, input variable C. Here also one NOT gate is connected, we'll get C bar, right? So A, B, C available, as well as A bar, B bar, C bar also available. 6 possible inputs are available. According to our requirement, we can connect. So the 3 inputs are there. One more input, this is the enable. Right. Now we'll see how we'll get the 8 different outputs. See this, for the Y0 is 0, 0, 0 mean we will get Y0 as 1 output. How it is possible? We are connected A bar, B bar and C bar. A equal to 0 mean A bar will be 1. B equal to 0 mean B bar will be 1. C equal to 0 means C bar will be 1. See, all are 1. So that we are getting 1 as a output. For all other outputs are zeros. What will become 0? Because see this 0, 0, 0. So these two are 0 being is 0, 0. A bar, A0 means A bar will be 1. B bar will be, but C is 0. So we'll get 0 as a output. Right? So for the combination 0, 0, 0, we are getting 1 because we are connected A bar, B bar and C bar. So automatically it become 1 and produce 1 as a output. Then next combination 0, 0, 1. So A0 means A bar will be 1. B0 means B bar will be 1. C is already 1. So here also we will get as a out. For the next combination we will get Y1 as a output 1. For the third combination 0, 1, 0. Right. A is 0 means A bar will be 1. B is already 1. C is 0 means C bar will be 1. So all are 1. So we will get the 1 as a output for the combination 0, 1, 0. Right. Similarly, we will see the other remaining outputs. So for this, we are having 0, 1, 1. For the 0, 1, 1 combination, we are getting 1 as a output. How it is? A0 means A bar will be 1. B and C is already 1. So all are 1. So we are getting 1 as a output. Then for the next combination, 1, 0, 0. We are getting 1 as a output. How it is possible? A is 1. B is 0 but B bar will be 1. C bar will be 1. We are connecting like that. We are connecting A, B bar and C bar. So B is 0 means B bar will be 1. C is 0 means C bar will be 1. So all are 1. We are getting 1 as a output. Right. The next combination 1, 0, 1. We are getting Y5 as a output. How it is possible? A is 1. B is 0 but B bar will be 1. C will be already 1. So we are getting 1 as a output. Right. The next combination 1, 1, 0. So A is 1, B is 1, but C is 0, C bar means 1. So we'll get Y6 as a 1. Here all are 1 only. Already for this ABC 1, 1, 1, we are getting 1 as a output. So all are already 1. So we will get Y7 as a 1 output. Right. So from 3 inputs A, B, C, we are getting 8 different outputs 0, 0, 0, 0, 0, 1 start from up to 1, 1. How it is possible? We are connecting the data accordingly. 0, 0, 0 means we are connecting A bar, B bar, C bar to the AND gate. So we are getting automatically we are getting 1 as a output. Similarly 0, 0, 1 means A bar, B bar and C is connected. A is 0 means A bar is connected. So we are getting the corresponding output. So in this video we discuss 3 to 8 decoder. From 3 input how we are getting 8 different outputs. We discussed the truth table and followed by the logic diagram. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the design of 4x16 decoder using 3x8 decoders. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Design of 4x16 decoder using 3x6, 3x8 decoder, 2 types, 2 numbers. Right. We know that decoder is a device having n input and 2 to the power n output. N input and 2 to the power n output. Here n is 4, 2 to the power 4, 16. 4 inputs and 16 outputs. Here n equal to 3, 2 to the power 3, 8 outputs. 3 inputs and 8 outputs. So we need to design the 4x16 decoder. 4 input and 16 output decoder. So here 3 into 8. So 8 outputs are available. So that we are using 2 numbers. 2 into 3, 16 outputs we will get. Right? 2 numbers of 3 into 8 decoder we are using. So here 4 inputs are available. Let us consider A, B, C, D. 4 inputs A, B, C and D. Here we need 3 inputs. Only 3 inputs are needed. So we can use A, B, C as a 3 inputs. And D is used for enable these two, enable or disable these two decoders. We are using 2 decoders at a time. We can use only one decoder. Another decoder will be disabled. So this the input D is used to enable or disable the 2 decoders. So that we'll get the output from only one decoder at a given time. Now we'll see the logic diagram. So this is the logic diagram. We are using 3:8 decoder number 1 and number 2. It is named as top and bottom. Top decoder and bottom decoder, having 3 inputs and 8 different outputs. 3 inputs and 8 different outputs. Right. So out of 4 inputs available in 4 into 16 decoder, A, B, C is connected as the input of this 3 into 8 decoder. A, B, C, first 3 inputs. The same input connected to the bottom decoder also. Top decoder and bottom decoder, the input is A, B, C. Right. One more input D is used for enabling this top decoder and bottom decoder. So it is connected as a enable input. So it is inverted. So it is 0. D equal to 0 means here 1 will be there. So the top decoder will be enabled. If it is 1, it become already one inverter is available. So this bottom decoder will be enabled. At that time here it become 0. Right? D equal to 0, top decoder enabled. D equal to 1, bottom decoder will be enabled. So while enabling top decoder, we will get 8 different outputs, Y0 to Y7. Right, that is D0 to D7. At that time, bottom decoder is disabled. When bottom decoder is enabled, these outputs are 0. Only we will get these outputs. So totally we are getting from D0 to D7, then D8 to D15. 16 different outputs will be available. Right. So out of 4 inputs, we are using 3 inputs for these 2 decoder. 4th input is used as enabling this top and bottom decoders, so that we are getting output from one decoder at a time. At that time, the output of second decoder is 0. Similarly, while enabling this bottom decoder, we will get the output from this, and these outputs are 0. Now we'll see the truth table for the further understanding. So this truth table is available here. The D equal to 0 means top decoder is enabled and bottom decoder is disabled. So that we'll get the data from D0 to D7, D8 to D15 will be 0. If D equal to 1, bottom decoder is enabled and top decoder is disabled. Bottom decoder means we'll get the data from D8 to D15. At that time, D0 to D7 is 0. All inputs, all outputs are 0. Right? So D equal to 0, we'll get data from D0 to D7. D equal to 1, we'll get the data from D8 to D15. Now we'll see the truth table. So this is the input A, B, C. A, B, C is connected to both top decoder and bottom decoder. This D is used for enabling the top decoder or bottom decoder. So this is the top decoder, D0 to D7. This is bottom decoder, D9 to D15. Right. We will see what will happen if D equal to 0. First combination, D equal to 0. So the D equal to 0, in that time this top decoder is enabled. The all inputs of bottom decoder are 0. All are zeros. Right. In this D equal to 0, another 8 combinations available because of 3 inputs A, B, C. There are 8 combinations. 2 to the power 3, 8 combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, like that. So based on these 8 combination, we'll get the 8 different outputs here. Right. We will see how it is we are getting. So D equal to 0, top decoder is enabled, bottom decoder is disabled. So output of bottom decoder, all the outputs from 8 to 15 is 0. Now we'll see how it will get the 8 different output from the value of ABC. 0, 0, 0 means the D0 will be 1. Other digits are 0. 0, 0, 1 means D1 is 1. D1 output is 1. Other digits are 0. 0, 1, 0 means D2 output. The terminal D2 output will be 1. Other digits are 0. 0, 1, 1 means D3 will be 1. Other digits are 0. 1, 0, 0. Then D4 will be 1. The D4 output will be 1. Others are 0. 1, 0, 1 means D5 output will be 1. Other digits are 0. 1, 1, 0. D6 output will be 1. Others are 0. 1, 1, 1 means D7 output will be 1. Other digits are 0. So based on this 8 combination, we are getting 8 different outputs starting from D0 to D7. D8 to D15 will be 0. Right. Now if the D is 1, again another 8 more combinations are there. If D equal to 1, what happened? This bottom decoder is enabled now. The output of the top decoder, all the outputs are 0. All the outputs are 0. Only with the bottom decoder will get the output. So bottom decoder is now this disabled. Top decoder is now, top decoder is disabled and bottom decoder is enabled. Again we have 8 combinations are there. 0, 0, 0 means we will get D8 output is 1. Other digits are 0. 0, 0, 1 means D9 output is 1. Other digits are 0. 0, 1, 0 means we will get D10 output is 1. Other digits are 0. 0, 1, 1 means D11 output is 1. Other digits are 0. 1, 0, 0 means D12 output is 1. Other digits are 0. 1, 0, 1 means D13 output will be 1. 1, 1, 0 means D14 output will be 1. 1, 1 means D15 output will be 1. So that we are getting this 8 different output because of these 8 combinations of ABC when D equal to 1. Right. So when D equal to 0, we are getting 8 different outputs. D0 to D7. When D equal to 1, we are getting another 8 output. D8 to D15. So totally we are getting 16 outputs. Right. D0 to D15. So in this video we discuss how to construct the 4 into 16 decoder. 4 input with a 16 output decoder using 2 numbers 3 into 8 decoder. Right. So out of 4 inputs, we are using 3 input for both the decoders. One more input is used for enable or disable the decoders 1 and 2. So that we are getting 8 different output when D equal to 0. Another 8 different output when D equal to 1. So totally 16 output we are getting. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we will see the design of 4 line to 16 line decoder using 2 to 4 decoders. 2 to 4 decoder. We know that decoder is a device having n input and 2 to the power n output. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The decoder is n input with 2 to the power n output. Here n is 4 and output is 2 to the power 4 16. 4 inputs and 16 output. We need to design 4 inputs with 16 output decoder using 2 input with 4 different output decoders. Right. So here 16 outputs are available. Here the output is 4 outputs. So we need 4 numbers. 4 numbers of 2 to 4 decoders are needed. So 4 into 4 will get 16 output. Right. Here how many inputs are there? If A, B, C, D. 4 inputs are available. Then 16 output. This 16 output will get 4 into 4 number of decoders. So we'll get 16 output. Then what about the inputs A, B, C, D? We are giving C and D. The LSB. The LSB least significant bit is given to input of all 4 decoders. C and D are given to input of all 4 decoders. These 4 decoders are selected by one more decoder. We need one more decoder in order to select these 4 decoders. That is decoder 1. So that is also one of the 2 to 4 decoder. In that A and B is given as a input, right? So out of 4 input, C and D is given to these 4 decoders in order to produce 4 into 4, 16 outputs. To control these 4 decoder, we are using one more decoder, 2 to 4, one more decoder. In that we are using the remaining inputs A and B. A and B 2-digit 4 combination. 0 0 means we will select the second decoder. 0 1 means we will select third decoder. 1 0 means we will select fourth decoder. 1 1 means we will select fifth decoder. So we can select this out of 4 decoder based on this combination. Now we will see the logic diagram. So this is the first decoder. We are giving A and B as a input. So we are getting 4 different outputs, D0, D1, D2, D3. This D0 is connected to the second decoder. When D0 is enabled, the D0 output is there, means the second decoder will be enabled. So that will get 4 different output. That is from D0 to D3. Suppose D1 is enabled. D1 is high output, means the third decoder will be enabled. So that we will get the output D4 to D7. D0 to D3 already available here. D4 to D7. At that time, only one decoder will be enabled. Either this or that. Suppose this D2, the third combination. D2 is high level, means the decoder 4 is enabled. So that we will get the output from D8 to D11. Suppose D3 is enabled, will the fourth decoder, fifth decoder is enabled. So that will get the output from D15, D12 to D15. Right. So totally we are having 15. So here 5 decoders are available. The first decoder is used to select out of 4 decoder for the 4 different combinations. The inputs are A and B. Right. So based on this value, these 4 decoders will be selected. So 4 into 4, 16 output will get. Then C and D is given to all the decoder. All the decoders are connected with the LSB input C and D. Right. So now it is very clear. In order to get the 16 output, we are using 4 numbers of 2 to 4 decoders. So that we are getting 16 output. The least significant git is given as a input C and D. To select these 4 decoder, we have one more decoder is available. That is numbered as now decoder 1. For that we are giving AB, MSB. So this first decoder will select the, out of this 4 decoder, it will select any one. So that will get the output. Right. Now we'll see the logic diagram. Now we'll see the logical truth table. So that we go for the further understanding. So this is the truth table available. The inputs A, B, C, D. There are 4 inputs. This is the 16 different outputs starting from D0 to D15. Right. We already know that this AB is given to the decoder 1. That is a selecting decoder. CD is given to the 4 different decoders. Right. So AB having 4 combinations 0 0, 0 1, 1 0, 1 1. Again CD having 4 combinations 0 0, 0 1, 1 0, 1 1. So totally will get 16 different output. Right. Suppose AB is equal to 0. AB equal to 0 0 means second decoder is selected. Other decoders are disabled. Only the second decoder is selected. Will get the output from D0 to D3. Remaining outputs are 0. Remaining decoders are disabled. Only decoder 2 is enabled. Will get the 4 different output. Decoder 3, 4, 5 all are disabled. Will get 0 output. Right. So A and B 0 0 mean decoder 2 selected will get the output from D0 to D3. How will get the output from D0 to D3? That is based on CD value. CD is 0 0. D0 will be 1. Other are 0. 0 1. D1 will be 1. Other digits are 0. 1 0. D2 is digit D2 is 1. Other digits are 0. 1 1. D3 will be 1. Other digits are 0. Right. So based on this CD value, 2 digit 4 combination, we are getting 4 different outputs. All remainings are 0. Now the next case for AB. If AB is 0 1, what happened? Decoder 3 will be enabled. we will get the output from D4 to D0. All other decoders are disabled. See this, only this third decoder is enabled. Second decoder, third decoder, second decoder, fourth and fifth decoders are disabled. Right. Now how will get the data from D0 to D7? Again 4 combination. 0 0 means D4 will be 1. 0 1 means D5 will be 1. Other digits are 0. 1 0 means D6 will be 1. Other digits are 0. 1 1 means D7 will be 1. Other digits are 0. So that we are getting 4 different output based on the CD value. Right. Now we'll go to the next combination of AB. 1 0. Suppose AB is 1 0. AB is 1 0. We'll see what happened. AB is 1 0 means fourth decoder is selected. So we'll get the output from D0, D8 to D11. Right. The second decoder is disabled. Third decoder also disabled. Only fourth decoder is enabled. Fifth decoder also disabled. Right. Now how we'll get this D8 to D11 based on the CD value. 0 0 means D8 will be 1. Other digits are 0. 0 1 means D9 will be 1. Other digits are 0. 1 0 means D10 will be 1. Other digits are 0. 1 1 means D11 will be 1. Other digits are 0. So we are getting 4 different output. Now the fourth combination of AB 1 1 means decoder 5. Last decoder will be selected. We'll get the output from D9, this D12. D12 to 12, 13, 14, 15. D12 to D15. Right. How we'll get this D12 to D15? Based on CD value. CD is 0 0 means D12 is 1. Other digits are 0. 0 1 means D13 will be 1. Other digits are 0. 1 0 means D14 will be 1. Other digits are 0. 1 1 means D15 will be 1. Other digits are 0. Right. The second decoder, third decoder, fourth decoder, all are disabled. We'll get the 0 output. Right. So finally we are getting the 16 different outputs are available. Starting from here, we'll get the 16 different outputs. Starting from D0 to D15, we are getting 16 different outputs. Right. So this AB is used to select the decoder, either decoder 2, 3 or 4, 5. This CD is giving the 4 different combinations, right? D0, D1, D2, D3 like that. So that we are getting 16 different outputs. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video, we'll see the 3 to 8 decoder IC. The IC number 74X138. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. The IC number is 74X138. It is a 3 to 8 decoder. We know that decoder is a device having n input, 2 to the power n output. N input with 2 to the power n output. Here the n is 3. So 3 inputs, 2 to the power 3, that is 8 outputs. 3 inputs with 8 outputs. So this 74X138 is a commercially available 3 to 8 decoder. It accepts 3 binary inputs A, B and C. And when enabled, provide the individual active low outputs Y0 to Y7. The output is having the inverted, so that we are getting the low output. Normally we will get high output. Because of inverted, we got low output. Now we'll see the pin diagram so are able to understand. The device has 3 enabled inputs. There are 3 enabled inputs are available. In that 2 are active low. G to A, G to B bar, G to A bar, G to B bar. This is our active low. And one active high, G1. G1 is the active high. So 3 inputs A, B, C, 8 outputs Y0 to Y7, that is active low output because of inverted output. And 3 enable inputs are available. In that 2 are active low, 1 is active high. Now we'll see the pin diagram. So this is the pin diagram of 74X138 IC 328 decoder. There are three inputs A, B, C with the pin number 1, 2, 3. In pin number 1, 2, 3 we have the three inputs A, B and C. There are three enable inputs are available. Pin numbers are 4, 5 and 6. Right? 4 and 5 having the active low enable input. Pin number 6 active high enable input G1. Right? This is the active low. G2A and G2B are active low. G1 is active high. G1 connected in pin number 6. These two are connected in G4 and G5. There are 8 possible outputs are available. Y0 to Y7. See, these are all inverted. All are inverted. So the pin numbers are, the Y0 is starting from Y0 15, 14, 13, 12, 11, 10, 9 and 7. Right. So these are all the output. These are active low. Active low. Normally we'll get only one output will be high, all other output will be low in the normal decoder. Any one output, any one pin will be higher, other pin numbers, other pins are low. For example, 1 all are 0, 0, 0. Otherwise 0, 1 all are 0, 0 based on the three inputs. Right? But because of active low here, only one output will be 0. All are remaining will be 1. It is inverted. Right? Normally only one will be there. All are 0. Here all output will be 1. Only one output will be 0 because of inverted outputs. Now we'll see the truth table. So the function truth table is shown below. The inputs A, B, C, three inputs and three enable inputs are available. G1, G2A, G2B and 8 outputs. Y0 to Y7 bar is inverted. Y0 bar to Y7 bar, all are inverted. Right. Now we'll see the enable inputs. Suppose G2B is 1. Whatever may be the remaining, we'll get all are high outputs. G2A is 1. Whatever may be the other inputs, we'll get the high output. G1 is 0. Whatever may be the other output, will get the high, all are high outputs. Right? So because of this active low, G2B or G2A is 1 means we are getting all our outputs. Normally we'll get all zeros, but here because of inverter we are getting all ones. Right? Whatever may be the other input, if this enable inputs are 0 means we will get 0. Because of this inverter, here 1 means we are getting 1. Here active low, so it is 0 means here also we will get 0. But because of complemented we are getting 1. Right? All are inverted. Now we will see the other combinations. So this is based on the enable input. If enable input G2B is 1, all are 1. G2A is 1, all are 1. G1 is 0, all are 1. Now we'll see other 8 combination. The three inputs are A, B, C. So we have 8 different combinations available. In that case, G2B is 0, G2A also 0, only G1 is 1. When G1 is 1, we will get the 8 different outputs. In that case, other two enable inputs should be 0. Right? For other cases, this is the other cases. Right? Now all the cases, G1 is higher. Right? Here A, B, C 3 digits available, so 8 possible outputs are there. 0, 0, 0, 0, 0, 1, 0, 1, 0 like that. So based on the 8 combination, we are getting 8 different outputs. A, B, C 0, 0, 0 means Y0 bar is 0. All other terms are 1. That is inverted. Normally all will be 0, only Y0 will be 1. Because of inverted output, Y0 bar is 0, all other outputs are 1. 0, 0, 1 means Y1 bar is 0, other digits are 1. 0, 1, 0 means Y2 bar is 1, other digits 0, other digits are 1. 0, 1, 1 means Y3 bar is 0, other digits are 1. And that 1, 0, 0 means Y4 bar is 0, other digits are 1. 1, 0, 1 means y5 bar is 0, other digits are 1. 110, y6 bar is 0, other digits are 1. Finally, 111 means y7 bar is 0, other digits are 1. So based on this ABC 3 digits 8 combination, we are getting 8 different outputs starting from y0 bar to y7 bar. Right? These are all zeros, other terms are 1. So in this video we discuss the 3 to 8 decoder. The number is 74x138, right? Having 3 inputs and 8 different outputs. In that the outputs are inverted outputs. So we are getting only 1 0 and others are other outputs are 1. And also we are having 3 different enable inputs are available. G1 is the normal high input, active high G1. G1 equal to 1 means we are getting 8 different output. Other two enables are G2A and G2B, that are active low enable inputs. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Welcome viewers. In this video we'll see the realization of Boolean function using the decoder. Example 1. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. The problem is we need to realize the Boolean function using the decoder. The problem statement is implement Boolean function f equal to sum of min term 1, 2, 3, 7 using the 3:8 decoder. By using 3:8 decoder, we need to implement this Boolean function. We know that decoder is a device having n input and 2 to the power n output. Here 3 inputs are available, 2 to the power 3, that is 8 outputs are available. So up to 7 is there. So definitely we need 8 different outputs, 3 digits with 8 different outputs, right? The step 1 is connect function variable as input to the decoder. The second one, logically OR the outputs corresponding to the present min terms to obtain the output. This is sum of min term. So we are using OR gate at the output. Input side we are connected the required input variables. Output we are connecting the OR gate to get the sum of min term. This is sum of min term. We need to add this min term 1, 2, 3, 7. Right. Now we'll see the logic diagram. So this is the 3 to 8 decoder. 3 inputs A, B, C and 8 different outputs. This is enable input. 3 inputs are A, B, C. Right. So based on this A, B, C value, we'll get the 8 different outputs. Right. 3 digits, 8 possible combinations are available. For example, A, B, C may be 0, 0, 0. If all are 0, 0, we'll get the output high here 1. Other digits are 0. 0, 0, 1 means we'll get the high output here. Other digits are 0. 0, 1, 0 means we'll get the high output. Other digits are 0. 0, 1, 1 means we'll get the high output. Other digits are 0. So these 3 is the input and this is the output, right? The first 3 digit input, this is output. Then 1, 0, 0 we'll get the 1 as a high output. Then 1, 0, 1, then 1 as a high output, other digits are 0. Then this is 1, 0, 0, 1, then 1, 1, 0, we'll get 1 as a high output. Finally 1, 1, 1 means we'll get the high output, right? So based on the 3 digits A, B, C, there are 8 combinations available, 0, 0, 0, 0, 0, 1. 0, 0, 0 means this output will be higher, all other output will be low. Y1, 0, 0, 1 means Y1 will be higher, other outputs are 0. So correspondingly what we'll get here, we'll get 0, 1, 2, 3, 4, 5, 6 and 7 as a output. So what we need in the given function is given as 1, 2, 3, 7. These 4 min terms. So we are connecting the corresponding outputs Y1. So here we'll get 1 as the output. So Y1 is connected. Y2 is connected, Y3 is connected. Then Y4, Y5, Y6 is not needed. Then we connected Y7, right? Y1, 2, 3, 7. These 4 inputs are connected. So this is sum of minterm. This OR gate will add these minterms and give the output. The required Boolean function will be available at this output, right? So 3 inputs, based on the 3 input, the 8 combinations are there. The 8 possible outputs will be there, 0 to 7. What we need is 1, 2, 3, 7. So only 1, 2, 3 and 7 is connected. So this OR gate will add all these 4 inputs and give the required Boolean function. So in this video we discussed the implementation of Boolean function using the decoder. The input is connected, output, 8 possible output is available. What are the terms we need? That alone connected to OR gate and we'll get the required Boolean function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. Viewers, in this video we'll see the implementation of Boolean function using the decoder. Example 2. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to implement the Boolean function using the decoder. The function given as f of w, x, y, z. These 4 inputs equal to sum of minterms 1, 3, 5, 6, 11, 14 and 15. 1, 2, 3, 4, 5, 6, 7 outputs are available. We know that decoder is a device having n input and 2 to the power n output, right? So here 4 inputs are available. So n equal to 4 and 2 to the power 4. That is 4 input and 16 outputs. So here 15 is available. Definitely we need 16 combination of outputs, right? So we need to use the decoder 4 inputs with the 16. 4 into 16 decoder. 4 inputs and 16 outputs. In that we will get the 16 different outputs. We need to connect the required outputs. Only 1, 3, 5, 6, 11, 14 and 15 can be connected. This is the sum of minterm. So we need one OR gate. All these inputs are connected to the OR gate. So that OR gate will add all these required minterm and give the final function f, Boolean function f. Now we'll see the diagram, logic diagram. So this is the 4:8, 4:16 decoder. A, B, C, D 4 inputs. Here given as W, X, Y, Z. W, X, Y, Z is a 4 inputs. We'll get the 16 different outputs are available. 16 possible outputs will be available. Right. Now we'll see how we'll get the output. So based on this value, there are 4 digits available. So there are 16 combinations. 2 to the power 4, 16 combinations, 0, 0, 0, 0, 0, 1, like that. For every combination will get the output, right? For example, 0, 0, 0 means here y0 will be 1. So this is input, this is output, right? So wxyz, that is wxyz is 0, 0 means y1. Here the output will be 1. Other terms are zeros. All other terms will be 0. So the corresponding minterm is here 0. Then 0, 0, 0, 1 will get here 1 as the output. 0, 0, 1, 0. Here 1 as the output. Other terms are 0. 0, 0, 1, 1. 1 as the output. Other terms are 0. Then 0, 1, 0, 0. 1 as the output. 0, 1, 0, 1. 1 as the output. 0, 1, 1, 0. 1 as the output. 0, 1, 1, 1. 1 as the output. So and next term is 1, 0, 0, 0. 1 as the output. 1, 0, 0, 1. 1 as the output. 1, 0, 1, 0. 1 as the output. 1, 0, 1, 1. 1 as the output. Right. The finally it is 1, 1. 1, 1, 0, 0. 1 as the output. 1, 1, 0, 1. 1 as the output. 1, 1, 1, 0. 1 as the output. 1, 1, 1, 1. 1 as the output. Right. So this is the 16 combination. Based on that we'll get the output. For example, W, X, Y, Z is all are 1 mean Y15 will be 1. All other terms will be 0. That is the basic function of the decoder. Only this output is 1, other outputs are 0. Similarly, Y14, 1, 1, 1, 0. W, X, Y, Z is 1, 1, 1, 0 mean this Y14. This pin will be available with the 1 as a output. All other terms are 0. So this is corresponding to the min term. This is 15, 14, 13, 12, 11. So what we need, that alone can be connected, right? So what we need is 1. We need 1. So 1 is connected. Then 3 is connected. 5, 6, then 11, 14 and 11, 14 and 15 are connected. So the required terms are connected. So 0 to 15 output is available. Here 0 available, here 1 available, 2 up to 15 available. But what we need is 1, 3, 5, 6, 11, 14 and 15. Only these 7 inputs are connected. This 0 is not connected, 2 not connected, 4, 7, 8, 9, 10, 12, 13 are not given in the min term. So that these outputs are not connected. Only required 7 outputs are connected. So this OR gate will add all these 7 inputs, 7 outputs and will give the final Boolean function, right? So in this video we discuss how to implement the given Boolean function using decoder. We are used the 4 input with the 16 output, 16 different output. Based on the 4 input values, that is 0, 0, 0 or 0, 1, 0, 0, 1, 1. Like for that, we are getting 16 combination of output. In that, the required terms are connected using OR gate and will get the final Boolean function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.